I know it will be a little bit weird doing notes this semester, especially with them all being online. I will not be grading notebooks, of course, or checking your notes, but I recommend taking notes as we go through it, putting it on line paper, putting it in a notebook paper, the same ones you had before, or starting a new one. These videos will stay online, but I recommend taking notes as normal. That helps you understand the material. And the first thing we're going to look at is radians. So what is a radian and how do they compare to degrees? So kind of the main thing about radians that kind of helps you think about it in a different way is it's just another way to measure an angle. So just like inches and centimeters, yards, feet is a different way to measure length. Radians is a different way to measure an angle. So if we look at an angle, a couple things to start off with, just the basics of what an angle is. So if you look at an angle, it has two rays and a point here. That point is called the vertex. And then it has two sides, or two rays here. Often this side here can be called the initial side. So we know that's where it starts, and then it goes away from it. This would kind of be the coterminal side, which means where it stops. So the angle goes this direction. So you can have angles going either way, which is something we'll talk about here. So coterminal side, also known as terminal side. So either of those work. So yeah, coterminal or terminal side. So when you look at an angle, it has a vertex, initial side, and it can go either direction. So a couple things about it when we're looking at angles in terms of trigonometry. We have a general coordinate plane. And what we often have is the x-axis here is the initial side. So it starts from the origin, this would be the vertex, and it goes out here. That's the initial side. So the x-axis is the initial side, and then it goes someplace out. So let's say it went here. That could be the terminal side. So the angle went this direction, started at 0 basically, and went all the way around. Okay, you can also have angles that go in the negative direction. This is black, of course. So let's say I have the exact same thing. X and Y, this would also be Y. So if I had, again, the x-axis would be the initial side, and then it could go either direction. So let's say it went this same angle here. Instead of going counterclockwise, it could go clockwise, and that would be a negative angle. So a negative angle is a clockwise rotation. While a positive angle would be counterclockwise. One interesting thing about this is, let's say we just guessed on the angle measurement here. It wouldn't be exact, but let's say we guessed. Let's say this is about 130 degrees or so. So if that was 130 degrees in a positive direction, or counterclockwise, we actually can know the negative direction as well, because the entire way around the circle is 360 degrees. So you would take 360, subtract the 130, and that means you'd have, what, 230? So this would be a negative 230 degrees this direction. Okay, so that's a little bit about standard position, how it starts, both positive angles and negative angles. So that same exact angle could either be negative 230 or positive 130. Okay, so let's look now at radians. So that's the basics about just what an angle is and how it can look on a coordinate plane. But let's look briefly here at radians. So like I said earlier, radians are another way to measure an angle. That is not spelled correctly. Okay, they're another way to measure an angle. And when we look at it, it's done in terms of pi. So if you think about it, like actually 180 degrees, we instead of calling that 180 degrees, we actually call it pi radians. Or 360 degrees is the same thing as 2 pi. And the reason that works out, and you can see this in the Khan Academy video, is if you think about circumference. So circumference equals, put it over here, circumference equals 2 pi, which would be the entire way around the circle, which is the same thing as 360. And so then it cuts it in terms of percentages of 2 pi. So if it was half a circle, it'd be 180 degrees, or pi in terms of radians, or in terms of radians or circumference. Or a fourth of a circle would be pi over 2, because it'd be 2 pi divided by 4, and so forth. So that's kind of how you think about it. It's where it ends up in terms of the entire circle. If you think about it in terms of a coordinate plane again, so if we have this here, in terms of radians, this would be 0 radians, or 2 pi, it'd be the entire way around. If I was going counterclockwise, or the positive direction here, this direction, halfway around the circle would be pi. Halfway between 0 and pi would be pi over 2. And then this would be 3 pi over 2, or 1.5 pi. If you went reverse, negative direction, again, it would just be the same thing, but in terms of negatives. So if I, again, make a... So if it went negative direction this way here, this would be negative pi over 2, negative pi, and then negative 3 pi over 2. Again, it can go either way around the circle, starting at 0, and then again back to 2 pi, because that's the entire way around a circle. Okay, so that's a little bit about radians, how it works. I can give you some examples here so you can look at it, so when you try the bookwork or try the online homework, it'll make some sense. So let's say we have a question that asks us, what quadrant is, let's go with pi over 5, and let's do negative 11 pi over, let's pick a number, let's go with 2 again. Okay, so what quadrant are those two? Is pi over 5 and in. So really quick before we try this, remembering quadrants, this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Okay, so those are our quadrants. Then if I look at the first one here, the pi over 5, so look at that part, and look back at my notes from above, so where it'd be going, so it's a positive number, which means if I look at my unit circle, or not my unit circle, my coordinate plane, sorry, we'll be doing unit circle later. So I'm starting at 0 here, I'm going this direction, and I'm only going pi over 5. So I know that this is pi over 2, or half pi, this is pi, and this is down to what, 1.5 pi. So this is the same thing, pi over 5 is the same thing as 1 pi over 5, which is not even half of a pi, so 1/5 pi is less than half, so it's someplace in this region here. So I'm going to go just a line right about here, probably would be this angle. This would be the angle, so it would be in quadrant 1. The second angle here, negative 11 pi over 2, is much more challenging actually. because it's negative for 1, which means I know in terms of my plane here it has to go this direction. But 11 pi over 2 is more than 2 pi. Remember, this is at 0. It's also the same thing as 2 pi because it's the entire way around. Because if you make an entire way around, that would make a circle, which is the same thing as 2 pi, or circumference of 2 pi. So I have to think about how many times this goes around first. So if I'm looking at this, I know to get 2 pi, it has to be 4 pi over 2, because it's being divided by 2 here. So that means if I look at this part here, I know that it goes around and it's negative. So negative pi over 2. I know it has another negative 4 pi over 2. That would make a total of 8 pi. And I know it has, after that, it still has a negative 3 pi over 2 left. Right? Because negative 4 plus negative 4 is negative 8, plus a negative 3 is a negative 11. So that's the top all added up. This goes all the way around the circle once. This goes all the way around the circle again. And then I have this left over. So the way to think about that is, again, this is my initial side here. It goes around 1 time. That is 2 pi. That is this first one right here. I went around once. I then have to go around again. That's that one. The next part right here. And then I have to go to negative 3 pi over 2. And again, if I'm going negative, this is negative pi over 2, because the exact same thing as the positive direction, but now in the negative way. This would be negative pi. This would be negative 3 pi over 2. Which means this question is kind of a bad question. I picked a bad angle there. So if I go 3 pi over 2, it goes all the way from here around to this spot right here, which means this would be the angle. It went around twice, and then it hits that exact line right there, which means they asked me what quadrant is it in. It's not actually in any quadrant. It's actually just the y-axis. So it does not hit any quadrant. It's not in the middle of anything. It's actually the y-axis right here. It actually makes a 90-degree angle after going around twice. So that's the angle we're looking at there. Okay. Another question it could ask you on the work is to sketch an angle in standard form. Which is basically what we just did, but now we're going to just sketch it, not have to actually say what quadrant it's in. So let's say we have 2 different questions here. Let's say it told us, let's go 7 pi over 4. And let's do a second one of just the number 3. So if I do the first one here, I know it's a positive number, so I have to go a positive direction. I know it starts here at this line. Okay, it starts at 0, and 7 pi over 4. So this is pi over 2, pi, 3 pi over 2. So I have to look, where does 7 pi over 4 fit? So first off, and this goes back to 2 pi. Is 7 pi over 4 more than pi? Did I go all the way past pi here? And the answer would be yes. 4 pi over 4 would be just pi. And then I go to this next one. Is it more than 1.5 pi or 3 pi over 2? And the answer would be yes. That would be 6. So actually it goes someplace here in between these two, and this would be the standard form of that angle. Okay, if I did 3, again, looking at the same radian idea, it's a positive again, so I have the positive numbers, 0, pi over 2, pi, and 3 pi over 2. This one's strange because you'll notice right here there's no pi. It's the first one we've done without a pi. It's just a number. So you have to think of where it goes on the line. So this would be 0 again. This is my, again, initial angle. So think of pi and think of 3. Is 3 more or less than pi? 3 is slightly less than pi. So I'm going in the positive direction. It's slightly less than pi, which means it's someplace right about here. And that would be the angle for 3. I know this is a little weird. If you have questions, you can let me know. But you can also check the videos out on Khan Academy. This is a quick idea of what a radian is and how you can figure out the difference between a radian